Liquid petroleum gas or LP gas in short term is essential for households these days. Human consumes gas every day for the fulfillment of their needs and wants, but gas leakages from household gas cylinders and other related appliances can cause huge damages and destructions if not properly taken care of. Causing potential fires and emitting vicious gases may lead to property damage and life harms too. Gas leakages can happen at any time due to various reasons, people's carelessness being one of the main reasons. For households, currently there are gas leakage and smoke detectors involved that can be installed, which only notifies the people when they are actually inside their households. But what if no one is present inside the house? Is there a way to notify about a gas leakage and a potential fire to the owner of the particular residence? It would be a better option for the owners of the house to get notified as soon as a gas leakage occurs inside their household premises. Since the modern communication and mobile devices have been developed technologically, it would be convenient for the members of the house to get notified about a gas leakage as in the form of an SMS or a voice over IP call. This innovation caters that specific requirement, allowing the users more reliable and accurate alerting system against severe gas leakages and potential fires. So as a solution for this problem, I have developed an automatic LP gas leakage alerting system. This system is solely based on IoT and consists of both hardware and software segments. The main device which is used to sense a gas leakage is shown here. Because of the time constraint and other limitations, I wasn't able to prototype the PCB for this device. But with the PCB as shown in this 3D view, it can be made in a compact way and will be easy to install within a compact housing. For the hardware part of this system, I have used MQ2 gas sensor as my sensing device exposed to the external environment. This senses the LP gas level of the atmosphere and changes its resistance for detection of change in gas levels. It operates under 5V DC and communicates serial data into the Atmega 328P microcontroller that I am using to display the gas level values. I have used an Arduino board and configured it as in the display for a 16:2 LCD I2C display. It shows the LP gas levels and smoke levels and changes in real time. I2C communication between the MCU and LCD has been configured. I have used a Node MCU development board to make use of its ESP8266 Wi-Fi module to act as a data transmission gateway. It is powered with 5V DC external power supply. This ESP8266 Wi-Fi module is used to connect to the home Wi-Fi network and to build up the connection with the backend cloud IoT platform that I am using. The MQ2 sensor data will be stored temporarily before transmission in the flash memory. For programming the hardware, I have used the Arduino IDE with all the relevant commands and libraries added. Since I am using ESP8266, the relevant board has been installed and properly configured. The sensor data, which is taken from the MQ2 sensor, can be visualized in its numerical values, and the real-time data transmission can be viewed as well as shown in here. I am using ThinkSpeak, which is an IoT analytic and remote data visualizing platform, in order to act as a dashboard for the user of this system. Users of this system has the capability to log in at any time and visualize their home's atmospheric gas level with exact values. It provides a user-friendly interface and accessible through mobile phone or a desktop computer. The connection is made using an API key which is defined as HTTP GET requests. To have the SMS service, I am using IFTTT webhook service to trigger an event and to send an Android message to a specified phone number belonging to any network. The connection between webhook service and ThinkSpeak is declared by an API key and a connecting URL. The relevant applet is then detected by ThinkSpeak. Then the trigger action is configured using a React app Here, the gas level is surpassing 60, but in actual condition, it should be 150. But for demonstration purposes, I have specified it as 60 for easiness. In idle mode, after powered up, the sensor keeps on sensing and data is pushed towards ESP8266, which acts as the gateway. Here data is getting updated every 1 second and the transmission can be accurately viewed, meaning whether it's successful or not. The pushed data can be visualized in the dashboard in real time. The dashboard has a gauge widget to display the gas level in numericals and to indicate different gas level at a certain time. The line chart widget is used to visualize past data. Now to demonstrate the SMS alerting process, I am using an LP gas lighter here. As soon as the sensor detects an increment in gas levels, it transfers the incremented values. And as in the video you can see that it has exceeded 60, which is the threshold value that triggers the SMS webhook service attached to ThingSpeak through HTTP. So in the dashboard also the real-time incremented values are updated. In a matter of time, the specified device which contains the number of inserted in the applets gets a message notifying that his or her household gas level has been increased past the threshold value. So if I talk about the advantages of the system, there are many that can be identified. One is safeguarding households from gas leakages and potential fires. Another one is alerting users even if they are away from their houses. So that's the main advantage that gives it from the traditional smoke detectors that we are having these days. And also remote monitoring and data visualization of gas levels in household atmosphere. So this is the end of the description about my innovation. Hope this can be utilized in an effective way to prevent gas leakage related accidents. Thank you.